question 5 is asking us to calculate the number of milliliters of oxygen required to react completely. And that phrase makes me think we're going to be doing some stoichiometry here. With 500 milliliters of butane gas, if the volumes of both gases are measured at the same temperature and pressure. So let's do some stoichiometry here. We're going to be working sort of with the bottom 2 rows of our table, if you guys remember from last week. So I'm going to go ahead and draw a little version of that. So if you guys remember, the ratio was the part that was at the bottom row of our stoichiometry tables. So we can go ahead and fill that out with the coefficients of our balanced equations. So we're not given moles. So how are we going to find that top row, or the second to last row if you think back to the table? Well, we are going to use what we just did. If you remember from our last problem, when you have the same number of liters of a gas, it's going to have the same number of moles in it. So we're actually going to work with milliliters because of that. It can kind of be a substitute for moles here. So we're going to fill in what we have. 500 milliliters of our butane gas. We'll go down the table, so we'll divide 500 by 2, gives us 250. And then we'll go up the table, so we'll multiply. So 250 times the 13 gives us 3,250 milliliters. Then we'll use that 250 again, multiply it by 8. That gives us 2,000 milliliters. Then we still use that 250, multiply it by 10, and we'll get 2,500 milliliters. So when you have 500 milliliters of butane with this exact equation going on, you would need 3,250 milliliters of oxygen, and that would give you 2,000 milliliters of carbon dioxide and 2,500 milliliters of water.